Hi, I'm Charlie Porter, and this is my video for my final project, which is on tracing the development of probability to the beginning of protostatistics through combinatorics. So my paper is about this evolution that led from combinatorics to probability to protostatistics. It started in the 6th century in India, where there was evidence of combinatorics, and then in the 9th century, Mahavira, still in India, actually found some of these formulas. But then in Islam, in the 13th century, Ibn Albana actually proved some of these formulas through induction, but not explicitly so. And then in the 14th century in medieval Europe, Levi van Gersten actually proved these formulas explicitly with induction. This led to 17th century European Blaise Pascal, who started probability theory using combinatorics, and my paper culminates in the 18th century with Jacob Bernoulli and Thomas Bayes, who used all this information to start statistics and protostatistics. So my problem is problem 3 from chapter 13, which states use the results of exercise 2 with A equals 1/3, B equals 2/3, and N equals 10 to calculate the probability that S is between 4 and 6, including 4 and 6. In the previous problem, we're given that the probability S equals R equals N, choose N minus R times A to the R times B to the N minus R. So this formula is actually found, this is the culmination, it was found by Bernoulli, and it's a variation on the binomial distribution, which is common in modern statistics. So let's solve the problem. First thing to note is that the probability S is between 4 and 6, including 4 and 6, equals the probability that S equals 4 plus the probability S equals 5 plus the probability S equals 6. So to solve this problem, we just plug in these values, 4, 5, and 6, each of these which is equivalent to R in this formula that we're given. So the first one is probability S equals 4, so that's going to equal 10 to 6 times 1/3 to the 4th times 2/3 to the 6th, which equals 210 times 1/81 times 64/729, which equals 0.2276. So we do the same thing for probability S equals 5 and the probability S equals 6, and we get these values, 0.1366 and 0.0569. So plugging in these values, we find the probability that S is between 4 and 6, including 4 and 6, equals 0.2276 plus 0.1366 plus 0.0569, which equals 0.4211. So this problem is at the end of my paper, and it really shows the development of combinatorics. It started with these formulas, these like choose formulas in this case, which were really founded in like the 9th century in India. And then also probabilities, these like 1/3 and 2/3 are found using probability theory. These are really probabilities. And it culminates in statistics where we can find the probability of something like this. So we're using all the combinatorics and probability to get to statistics, and it really shows how powerful combinatorics has led us to get in modern mathematics. It started with just finding possible combinations, and it's culminated with us using probabilities, indeterminate probabilities, to find an indeterminate solution, which helps us to both predict the future and explain the past, which is a very powerful tool. Thank you.